Okay, so today we're going to be looking at electrical power, electrical efficiency, and cost of electricity. So make sure you have your calculator actually before we start taking a look at this. Okay, so the term power, okay, so when we refer to power in terms of electricity, of course, we're actually looking at the rate at which energy is changed. Okay? Or you can think of it as how quickly is electrical energy being converted into whatever form of energy you're using. So for example, let's talk about a light bulb. A light bulb that is providing more energy per second will typically be brighter, usually, okay? So the quicker, or I should say, the more energy it can change in a certain amount of time, the more powerful or the more wattage it will have. So if I have, let's say, a 10-watt light bulb versus a 50-watt light bulb, okay? So really, the term watt is the unit for power. So remember, power is saying essentially how much energy is being converted in a certain amount of time, like the rate at which. So actually, a watt is equivalent to joules per second. So if you remember joules, actually we talked about this even in biology, a joule is a unit of energy. So the light bulb that is 10 watts is converting 10 joules of electrical energy into light energy for every second of time. The 50-watt light bulb is converting 50 joules worth of energy in 1 second of time. Or you can think of this as the 50-watt light bulb is actually converting energy 5 times more than the 10-watt light bulb. Right? So it's converting energy at a quicker pace. Right? There's more energy being converted, in this case, into light energy, or whatever the case may be for that particular load. So the higher the power rating or the wattage, the more electrical energy it will produce per second. Right? So if I wanted a lot of light, typically, let's say these were the same type of light bulb, the 50-watt bulb would typically be brighter than the 10 watts. Usually that's how that happens. Now, different types of loads will produce different amounts of power. So if I have, for example, and we'll talk about this in the next upcoming slide, but let's say one of these was an LED light and one of these was a regular incandescent light bulb. So meaning like one was the, or let's say one was a fluorescent bulb, right? So like the swirly bulb versus the non-swirly bulb. I'm not sure how familiar everyone is with light bulb terminology, but they're going to produce different power amounts, but actually the efficiency might be different. So for example, I can have a type of light bulb that has less energy converted, but maybe it's more efficient at converting that energy, so it'll produce a brighter light. So what we're doing here when we're comparing the powers of these two bulbs, we're looking merely, assuming that they're the same type. So meaning the load is using the same method of converting the energy. So here's an example of this. So we have an incandescent light bulb, we have an LED bulb, and we have a CFL, which is essentially our fluorescent bulbs, right? So here we have different watts. So this is 60 joules of energy per second. This is less than 10. So maybe let's, say 9 joules of energy per second. And this is 15 joules of energy per second. So the incandescent bulb, which is kind of your regular standard bulb, is using more energy. It's converting more energy per second. But if you compare the three, the light is actually not very different from each other. So yes, this is producing a lot of light, but actually, even though these are much less energy conversions, you still have the similar quantities of light that are coming off of them. And the reason for this is due to efficiency. So especially if you look at this LED, it's only converting 9 joules of energy per second, so it's much less than the 60, but the light is actually pretty bright. It's because the LED bulb is more efficient at the energy it's converting comparison to the incandescent bulb. And we'll talk about efficiency much more later on. But that's why there's a difference between different types of bulbs or loads. It's the same thing where, let's say you have 5 different types of hair dryers, right? They might be the same, I guess, type of load, right? They're all hair dryers, but one might produce hotter air with less energy than it needs. So it's a more efficient. And that's really what you would want, right? So think of it as, especially if you are starting to pay the bills, right? You want to have more efficient loads that are in your home, because what happens is you're using less energy and you're getting the same amount of usage, right? If I can have a hair dryer that's going to give me the same heat as a less efficient hair dryer, and it's going to cost me less to actually use it, that's what really you'd want to do, right? Now, usually the more efficient the load is, the higher the price is when you go to purchase them, right? So if you go to Home Depot and you compare, or any place, hardware store or place that sells light bulbs, and you compare these 3 types of bulbs, your LED bulbs will probably cost you more than the other 2. But in the long run, it's going to cost less because it's able to run on a lower amount of energy and give the same amount of light. So, in terms of measuring how much energy is being used, typically if you think of, energy that's used in your home, let's say. So we're using a lot of energy, right? We're not using just, let's say, 60 watts. Think of how many light bulbs there might possibly be in your home. Maybe you have a lamp, you have lights in your kitchen, you have lights in the bathroom, you have lights in a lot of different places in your home. So, and you also have to think this is per second, right? So if we're going to use this for, if the light is going to be on for an hour, it's going to be much more. You have to take 60 and basically figure out how many seconds are in an hour, right? So it'll be 60 seconds in a minute, and there's 60 minutes. So it'd be 3,600 seconds for every hour, right? So technically, you're using one light bulb that's on for even 1 hour is using a ton of joules. So when a homeowner gets the bill, the electricity bill, it's not a small amount, okay? So typically, we use the term kilowatt hours, okay? So 1 kilowatt, just so you know, is equal to 1,000 watts. Now, usually we discuss them in terms of hours because that's actually how you're charged. So on your, when you start paying the bills, or maybe you can ask your mom or dad or guardian to look at one of the electricity bills, you're charged per kilowatt hour of electricity that you've used. So the symbol for that looks like this, kilowatt hours, and it's a dot. So this is not, it's technically just the symbol for it. Or you can think of it as multiplication too. I know the dot represents multiplication when you're talking about mathematically anyways. But let's say electrical generating stations, right? So let's say the nuclear power plant in Pickering. They're not producing simply kilowatts, right? So you have to think that electricity is being sent to many, many different homes throughout Ontario. Now we're talking about huge quantities of electricity. So we have what's called a megawatt or a gigawatt, okay? So usually you don't see those values when we're looking at one person's home, but maybe if we were discussing, all of the electricity used in Richmond Hill, right, we would use larger and larger quantities. The one we're going to be working with will be kilowatt hours, and you'll see that come up again. Okay, so how do they know? How does, Hydro One or any electrical company, how do they know how much energy that you've used? For example, the month of April, how much electricity was used? So usually homes have what's called a smart meter attached. Now, if you live in a home, like not a condo or an apartment, but in a home where you can go in, like in the front door, on the ground level, right? So like a townhouse or a separate house or semi-detached, something where you are not in an apartment building or in a condo building, you may see one of these meters on the outside of your home. Usually they'll have them on the side of the house, or even in the front or in the back. But there is something that looks similar to this that has an electrical readout that will digitally say how many kilowatt hours are being consumed, and actually that it's always running. So this dial will continuously be reading all of the electricity that is being used 24/7. Now, if you do live in a condominium or in an apartment building, usually these are in a room. So every unit will have their own meter, same thing. The only difference is that usually these meters are kept sometimes in the basement, or there is an electrical room usually per floor. So there's probably somewhere in your hallway where there is a door that's maybe locked and only management or a superintendent can get in there. But every home, no matter what type of home you have, there is a smart meter somewhere there that is keeping track. Okay, because companies want their money for their electricity. Of course, electricity is not free. Back in the day, probably wondering, well, how did they get this information? So right now, everything is kind of wireless. So these digital meters will basically send information to the companies. But if you go to an older home, if you've ever seen one of the older ones, there's actually a dial. So it's like an analog dial that is actually read out with, it almost looks like a clock. There's a dial where they actually have to read the information. So it's not sent electronically. It actually has to be read by somebody. So they used to have to send somebody that would basically walk through neighborhoods and go to each home and record the data for the smart meter. Well, then I guess the meter wasn't so smart, but when you're looking at it, you would have to record it, and then essentially that they would charge you based on what the reading would say. But now we're much smarter now. Okay, so efficiency. So maybe I'll pause here and we'll look at the next part for efficiency.